The first are companies that have large requirements for concrete, such as those that are creating data centers all over the world. And many of those companies have ESG requirements that require them to get to carbon neutral by sometime between 2030 and 2050, and some even have them going to carbon negative by 2050. So we'll be working very closely with those to provide zero carbon and carbon negative concrete. And basically, as we go carbon negative and deliver carbon negative concrete, that offsets other carbon positive concrete within their data centers as well. So if you look at the construction project as a whole, it's the net of the negative and the positive to get them to zero, which is very exciting for us.
Yes, it's going to be yet another exciting story coming your way. So stay tuned for the full conversation. Hello and a big warm welcome to yet another episode on the Mission Shunya podcast. A special welcome to all the new listeners who are tuning to this on the YouTube music platform. Yes, that's one more addition to the different streams where you can find this podcast on. We are midway in our series around decarbonization of the construction sector. If you haven't listened to the previous episodes, please do check them out to understand why it is important to talk about the decarbonization of the construction sector and what are the key drivers and enablers to help us to get to that. As I was doing my research around this topic, a key component that I wanted to discuss was around alternative materials. Yes, in recent times, there are a bunch of early stage companies that are claiming to have an USP with their product or technology. In fact, I did speak to a few of them as a precursor to the actual podcast recording, which I generally do. Among them, there was one company which has also got backing from Microsoft that really stood out. So, who's our guest for today?
Hi, I'm Loren Burnett, President, CEO, and co-founder of Prometheus Materials.
So, Loren, let's begin with the origin stories of Prometheus Materials. So, how did this idea that was probably incubated in a university campus come about to life over a period? I think it was about close to 8 to 10 years in the making. So how did this all unravel?
Yes, so this started with a research project between the University of Colorado, 4 professors there, and the U.S. Department of Defense, DARPA, the Defense Advanced Research Projects Agency. And what DARPA was looking to do was they wanted to see if there was a way to use living materials like algae to create protective structures for things like troops and other high-value assets in the middle of the desert somewhere. And they knew that they didn't want to truck in concrete over potentially large expanses of hostile territory. And they knew they couldn't fly it in because of the weight, and so they wanted to see if there was a way that they could, create protective structures in situ with using local sand and resources. And so, over a 5-year process, what the professors from the University of Colorado came up with was this business of using algae and to stimulate it to micromineralize calcium carbonate, which is a similar process to what nature uses to create seashells and coral reefs. And so at the end of the 5-year period, they were extremely successful and had created a concrete alternative. What they realized at the end was that not only had they created an alternative to concrete and cement, but they had done so on a carbon neutral basis, and that was actually not part of the original plan with DARPA, but turned out to be a tremendous unintended consequence.
That's fascinating. Getting to a level like, say, carbon negative, that is really significant. So From that point till now, where the company is, so what has the transition been like? Because once you get to a level where when you can actually claim to be carbon negative, that means like it's a significant milestone, because cement and concrete production actually accounts for a huge amount of greenhouse gases. So what happened between that period to when you actually started commercial production?
Sure. So once the DARPA contract was completed, the University of Colorado, which actually owns the intellectual property, came to me and said, Loren, we're about to release a new product, a new technology, and we think it's great. It's been through DARPA successfully, and would you have an interest in taking a look at it to start a company? And so I met with the four professors, and this was back in 2021. So if you remember, we were right in the middle of COVID at that point, so nobody was meeting in person. And I met with the professors over Zoom, and once I realized what it was that they had created and that it was zero carbon, that became extremely interesting to me because, as you mentioned, um, you know, the production of cement and concrete are just very dirty from a climate perspective. 8% of greenhouse gas emissions come from the production of cement and concrete, and it's only going to get worse because of the growth in population worldwide, and therefore the growth in construction and the use of cement and concrete. So we founded the company. It was myself and the four professors, and then went out and raised a Series A, and we were off to the races at that point. An $8 million Series A back in 2022. Began staffing up, creating labs and creating R&D, and over the next couple of years, we've gone from a very early stage type of technology to where we are today.
That's very good to know. Now, getting back to the numbers, since you have actual results that claim that the product is actually carbon negative, so when you look at application and use cases, I have read through some of your press releases that you are actually probably going to do this as prototype for large construction sites. For example, I think even say something like a data center among key partners and players who actually are also keen to decarbonize the construction of, say, large commercial spaces, or even for the matter data centers. So what are the numbers like? How does it actually stack up compared to the conventional construction to using Prometheus materials or concrete, and what is it for a lifetime?
Yeah, so as you mentioned, the companies that have data centers is an area that we'll be heavily involved with. We really look at the market for this type of product. We really break it into three sections, three groups. The first are companies that have large requirements for concrete, such as those that are creating data centers all over the world. And many of those companies have ESG requirements that require them to get to carbon neutral by sometime between 2030 and 2050, and some even have them going to carbon negative by 2050. So we'll be working very closely with those to provide zero carbon and carbon negative concrete. And basically, as we go carbon negative and deliver carbon negative concrete, that offsets other carbon positive concrete within their data centers as well. So if you look at the construction project as a whole, it's the net of the negative and the positive to get them to zero, which is very exciting for us. The second group is a group that's kind of in the middle that is interested in reducing the carbon footprint, but and will pay some level of premium, but not unlimited. And then the third group is kind of one that only care about price, and if you happen to be carbon negative, that's great, but they're not going to pay a tenth of a cent more for that. Those are the three groups. Initially, we are focusing on that first group, which are the folks that have corporate requirements to get to net zero and carbon negative. And so where we come in early on is on the ready mix side. So we have delivered our ready mix product 9 months ahead of schedule. And so that is up and ready to go. And then from that is a product called FlowFill, which is what construction companies use that are building data centers to basically to fill in around conduit that's taking either communication or electricity into data centers. And so that is an excellent opportunity for us and is very, very large and can have a huge carbon impact.
So when you did mention about the roadmap across those three categories, so I kind of figured out that it could also be because the current production and the cost for the product probably is a little on the premium end. Is my understanding correct? And it would probably take some amount of scale up to kind of go to the mass market product section. Is it true?
Yeah, initially as we are beginning scale production, there will be somewhat of a green premium, and I kind of hate to use that term because it's really not a green premium in that sense. What if you look at the cement and concrete industry today? There are various ways that they are reducing the carbon footprint of concrete, and each one of those has a cost associated with it. Nobody can come close to taking it to carbon negative like we can, and yet our cost will be right around what current large companies are charging for, reducing the carbon footprint by say 30%. We're reducing it by 102%, and we'll be priced very similarly to those. So we don't look at it as a green premium. We look at it as we'll be right in line with the market for reduced carbon concrete.
That's fantastic. Apart from the green premium requirement, are there any other challenges or drawbacks that's kind of yet to be overcome as you scale up?
Just anytime you scale up a business, particularly to a global level, there are always challenges associated with that. We believe we're fully prepared to meet those challenges, and our model is a licensing model where we'll be licensing our technology to large producers of cement and concrete products worldwide. So what we're doing is we are leveraging those companies' abilities to produce a large scale and to distribute a large scale. Our role, in addition to licensing the technology itself, is to provide the algae and the biomineralized calcium carbonate to those companies. We're not asking any cement or concrete company to learn how to grow algae. We take care of all that and become basically a drop-in component to their existing production facilities.
That was exactly the kind of response I was looking for, because from the start of the conversation, you have been very clear that the technology is so mature and so promising that it has to be global. And as you rightly pointed out, this is going to be a license-based model where you're going to work with global players who can actually do the hard part of operationalizing the kind of product to the reaching the end consumer. So that is fantastic. But apart from this, do you think there is anything that will probably hold back in terms of modularity or scalability in terms of what this product can accomplish in terms of large constructions?
We do not see any major roadblocks. We're working through the process of working with the different regional and national and state building code organizations. We're making great progress in getting through the ASTM certification process. So that is something that we feel very good about. And once that takes place, then we'll be in a position to effectively address regional and local building codes as construction projects take place.
That's very good. Loren, so on a final note, so we did hear a lot about how it's going to be really useful, what are the positive upsides, and how you're going to scale up globally. So how does the roadmap look as a CEO of the company? How does the roadmap look? If you can share your insights for, say, for example, the next 2 to 3 years, where do you see the company growing, and what kind of projects what are your targets, if you may say? what does it look like?
Sure. So initially, we begin the scale up process with organizations in the Intermountain West region of the U.S. and then spreading to other organizations throughout North America. And after that, we then start to branch out to Europe, India, and Asia. And so, our process there is we're not asking companies and builders to completely replace traditional Portland cement-based concrete with our algae-based concrete. We think that's too far of a step initially. So what we're doing is we are basically mitigating risk by incrementally increasing and mixing our bio cement with traditional Portland cement-based concrete, and really kind of we're starting out at kind of a 70 to 30 type of ratio, and then moving up to 60-40 and 50-50 and beyond. So we believe that strategy is one that really will over time open up the world to knowing that they can use a bio-based zero carbon and negative carbon cement and concrete. So that's our process going forward. We fairly rapidly become both cash flow positive as well as profitable, and then from that point, it's just growing on a worldwide basis.
Great. So thanks, Loren. Thanks for taking time to join me on the podcast and sharing more about the origins story of the technology and what do you intend to achieve globally. So that was very insightful. And what I kind of learned and figured out while following and reading about your company is that, yes, the technology definitely looks promising, and getting to somewhere like a net carbon negative is something really wonderful. So really looking forward, and hopefully the technology scales up globally, and we definitely want to see a big positive impact from your end.
Well, thank you very much, and thank you for your interest in this area. And we look forward to seeing you over in India one of these days.
That was a wrap on this episode featuring Prometheus Materials, an alternative to concrete and cement on a carbon neutral basis. So it might be early days for the technology, but still the claims like being on the same cost side as the conventional players, but with the emission reduction potential of over 100% compared to the 30 to 40% range is a very big one. Well, it should also not be a total surprise because the example of Prometheus Materials has a synonym to biomimicry, where nature's processes have found similar mainstream adoption in large-scale technology adoption. Also, the solution that they are proposing is to be a drop in the entire component value chain to existing manufacturing facilities, which should be a big plus when it comes to global technology adoption of this novel innovation. The links to follow them are in the show notes section of this episode, so please do check that. And as always, missionchunya@gmail.com is the ID for all your feedback. Keep that coming. I know a lot of new requests have come for both guest recommendation and also for podcast ideas. So if you are one among the listeners who has sent me an email, a big thank you to you. And finally, the artwork is courtesy Team Terra Generation, a content agency specialized in telling stories in climate, biodiversity, and sustainability. So until next time, when I come back with yet another conversation on this series, this is Girish Shivakumar signing off, and as always, thank you for listening.